In an era where over 70 countries and more than 1,200 companies have committed to achieving net zero emissions by 2050, addressing carbon emissions from all sectors becomes paramount. The construction industry, traditionally viewed as a major contributor to carbon emissions, holds substantial potential for reducing its environmental impact. Yet, one facet of carbon emissions, known as embodied carbon, has often been overlooked. Embodied carbon, a derivative of the broader notion of embodied flow, encompasses all direct and indirect carbon emissions produced during the entire life cycle of a product, including gases like carbon dioxide and resources such as land, water, and labor. In the context of the construction industry, embodied carbon refers to the emissions linked with the production, transportation, installation, maintenance, and disposal of building materials. And like operational carbon emissions occurring during the usage phase of a building, embodied carbon remains fixed once construction is complete, exhibiting a strong carbon lock-in effect. While much attention has been focused on reducing operational energy costs associated with activities like heating and lighting, the cumulative carbon emissions generated during construction have often been considered locked in embodied carbon. Operational energy use, management, and maintenance of buildings currently contribute to more than 20% of global annual greenhouse gas emissions. In contrast, emissions generated during construction accumulate and are considered locked in until the operational phase commences. Embodied carbon accounts for more than 10% of global greenhouse gas emissions due to ongoing construction activities. As buildings become more energy efficient, the proportion of embodied carbon in total carbon emissions is projected to increase. By 2030, it is expected that more than 70% of a building's carbon emissions will come from embodied carbon, with the remaining 30% from operational carbon. The global construction industry is actively transitioning toward more environmentally responsible practices, with innovation playing a pivotal role. Here are 5 strategies to effectively reduce embodied carbon. 1. Transparent data for informed decisions. Providing transparent data that quantifies the environmental impact of materials and processes used in construction activities empowers professionals to make informed carbon reduction choices. Transparent data facilitates better decision-making by comparing environmental data of building products, enabling the selection of low-embodied carbon products or carbon-sequestering materials like wood. 2. Design optimization tools. Specialized design optimization tools, focused on product and material data, assist industry professionals in exploring, comparing, and selecting construction materials. These tools help evaluate various environmental factors alongside performance, durability, maintenance, and aesthetics. They leverage material data transparency to make sustainability an integral part of the design and construction process. 3. Environmental Product Declarations, EPDs, similar to food nutrition labels, display environmental data for materials that have been independently verified according to globally recognized methods. This ensures fair comparisons and helps professionals make informed choices when selecting materials. 4. Collaboration and data accessibility. Collaborative efforts in accessible data throughout all project phases, from planning to procurement, enable stakeholders to assess and compare product and material selections. This approach results in more sustainable outcomes by considering embodied carbon early in the design process. 5. Reuse and upgrade. Exploring opportunities to reuse and upgrade existing buildings is essential to minimize waste and demand for new resources, effectively reducing embodied carbon. As an industry with immense potential for carbon emissions reduction, the construction sector plays a crucial role in global efforts to combat climate change. Addressing embodied carbon, while acknowledging the importance of operational carbon, is essential for achieving sustainability goals. Transparent data, design optimization, EPDs, collaboration, and reusing existing resources are key strategies in the construction industry's journey towards a greener, more sustainable future. By embracing these approaches, construction professionals can not only build better structures, but also contribute significantly to the global fight against climate change. The clock is ticking, and the construction industry has the power to make a lasting impact.